Ladies and gentlemen, boys and girls, children of all ages, we are live. For the thousands of nuggeteers in attendance, okay, possibly one family member, and the millions of nuggeteers watching from around the world, okay, maybe 5 from Wisconsin, 2 from Illinois, and 1 from Texas. Temporarily Offline Radio presents Ham Nuggets, the fastest hour in ham radio YouTube. 60 minutes is 60 minutes. Yeah, I know. And now, here is your host, the man, the myth, the legend, if even in his own mind, KM9G, otherwise known as T.O.
Welcome back, everybody. This is Steve, KM9G, and I got to take a deep breath after that intro because it always gets me. Kurt, thank you very much for that. Got my special expert witness here, the Smoking Ape. How are you today?
I'm doing well. How are you?
I'm doing pretty good. Are you allowed to do expert witness stuff when you're in witness protection? I mean, out in Nebraska?
No, I'm actually as a freelance consultant.
Oh, okay.
Is
Pro bono.
Right.
Bono, as they say. Exactly. So we've got something interesting on the show. We kind of changed the format of Ham Nuggets, I don't know, about 2 months ago, maybe at this point.
Yeah, about.
Where we just try and do something interesting and ham related and explore some space. And so what I've got on the space to explore today is this thing. And my club has been playing with this thing for a while, and I brought it home to make some more improvements on it, and I need to make some more improvements on the improvements that I made. But this thing is a $7 MTM case card. I like MTM case cards products. You saw the battery box build that I did.
Who doesn't? Those things are great.
So this is an old ammo box, and I kind of took a wild guess that this was the right size for this big old capacitor that we've got in here. Let me get this lid out of the way. So these lids come off, and there's a little rubber gasket in there. So unless you do stupid things like cut holes in the side of the case, it's actually waterproof. And then you can see that this is a big old capacitor. And so what it says, let me see if I can get a good zoom in on there for you. Lighting is going to be kind of weird because of how I got it all set up. But it says velvet veneer. And it's a...
nice. That's what they used to call you in high school, right? Velvet veneer?
Well, it was velvet, but it wasn't veneer. Yeah.
Okay.
And so there's a bunch of stuff. And what I need to fix is down here, the SO239 connectors, and the lighting is a little weird there. The SO239 connectors on the side aren't properly wired up. So I'm going to put some spade connectors on the end of them. Well, not spring terminal connectors on the end of them, and use some better jumper wire and pretty it all up. But that isn't important for what we're doing tonight. Tonight, we're just going to try and figure out what we can do with this thing. And this is part of a magloop antenna. So I have a video on my channel where I compared the SWR scan in the 6100. I'm now the Zygu guru. I've compared the SWR scanner in this radio with the SWR scanner in the 705 using this magloop antenna as my guinea pig, because magloop antennas, if you don't know, are super high Q antennas. So they've got about this much bandwidth on them, this much, before you are out of the antenna's receivability. So,
it's about 7 or 8K, I believe, is what they say
lucky,
on those things.
Yeah. It's pretty tight.
When you think about that, that's really, two SSP signals, give or take.
Yeah, it really is that tight. And you just reach up and you turn this capacitor, and you can just watch the signals move on the waterfall in and out as you're going by. So we've got a couple of tools here to connect to this thing.
Well, hold on. Let me ask you some questions here. That
that
dial that you have on there, did that come with that cap, or is that an add-on piece?
So what I understand is that this came out of an old Yaesu tube radio, and it might be a Yaesu tuner. I'm not 100% sure, but this is a gear reduction tune.
Mm.
So
it
might just be
slow
because of how big the knob is. But yeah, so it moves real slow compared to the number of turns. So like one full turn is about a quarter of a turn.
Now, does
Yeah.
at the bottom of that, it looks like there was a secondary adjustment. Is that, or am I making stuff up?
You're making stuff up.
Because it looked like at the bottom it said like 5, 10, or 15 or something like that.
Yeah, so there's a 5, 10, or 15. You did catch that correctly, and I think that's just so that you can easily read it as it swings by.
Gotcha.
But there's nothing I can move there. And this thing's probably 2 or 3 pounds. It's a pretty beefy boy.
I was just say, what is that? 40 pounds? No, it is
Yeah.
a big one. So that's definitely cool.
So I'm 6'2", and it's about the size of my hand.
Nice.
So, folks in the chat, leave any questions you have about this thing, and we will do our best to put it as the device under test for the night. And that's what this is all about. Rod, N6NII, knows exactly what this thing is. And he says, yes, it came from some rig. And I was talking to Ape in the back chat in the green room before the show. And I said, Rod likes to go to Hamfests and buy variable capacitors. That's what he does in life.
If we know what rig it came from, we might be able to look that up and see what its range is.
So that was one of the questions that I had, was how much power can we put through this thing? And it looks like it can handle some power.
Well, with one of the things that when you the more power that you can throw through a variable cap like that, depends upon the size. I call them fins. I don't know if that's the right word for them or not. Blades. Those are pretty beefy. And they're spaced well, because the one thing that'll happen is with like a magloop or something like that, they are very, very high voltage, and you need to be really careful around them. So it's a good thing you have it all boxed up like that. But you will get arcing, and sometimes that arc will even fuse the fins or blades together if they are too thin and too close together. So
Dave is saying first we could measure it, and I'm getting about 4 inches tall on the reactive elements, and let's see about width. I'm getting 2 1/4 without taking it out of the box. Is that what you were looking for, Dave?
plates. That's what he's calling them, plates.
And this is the antenna tape.
There you
This
go.
is a pretty cool little tape measure that has antenna make-ins on it.
You were saying that that variable cap does not have any markings or engravings on the side of the chassis of the capacitor itself, right?
Oh, no, hold on. On the bottom here, I just saw this. Way down here underneath of the center post, it says 300 PF. So there we go.
So that probably means it has 300 picofarad range. Could be wrong about that, but so just because something has 300 picofarad range doesn't mean it goes from 0 to 300. Like it could go from 50 to 350. So the lowest that you could tune it would be 50 picofarads. The highest would be 350. I'm assuming with something like that, it's got a pretty, that size, it's probably got a pretty high picofarad rating as its starting point. But the only way to really measure that is with a capacitance meter.
And I do not happen to have a capacitance meter.
Well, maybe that's part 2.
Yeah, it could be. And Dave's saying it could go from 290 to 310. And he said, put it on a DMM and see what it says at both ends. So that's an interesting question, Dave. I don't understand how I would get both ends. So help me out with that a little bit, because I only know of 2 ends, and I really know how to measure it.
Yeah, what you could do with the
those 2 ends.
DMM is connect it to the chassis, which would be the ground, and then the stationary plate, which would be your hot.
Right.
Turn your capacitance setting on your digital multimeter, and then turn the knob all the way to the left to get the low end, and then all the way to the right to get the high end. Unless it's a reverse one. Sometimes those capacitors actually go in reverse.
So I'm pretty sure that I do not have a capacitance test on this meter, and I did not have a chance to get the other one.
Let's take a look at that
both
meter and
sides,
see which.
he means.
Yeah. See if you do have capacitance test on there. What it looks like is a T on its side and another T on its side. It's just a symbol for capacitance. I can't see through the. Maybe if you go single mode.
Yeah. So what I've got is the diode, and then the multimeter, the continuity test, and then I've got ohms readings throughout. And then I can do I think that's digital, sorry, DC amps, AC volts, DC volts. I think those are my choices on this meter, but it's not supposed to be that good of a meter.
So Canada Joe saying put it on NanoVNA, find the capacitive reactance at a few frequencies, and then do the math to find the capacitance. So we are going to NanoVNA it. I would need a refresher on the formula to find the capacitance. So the thing is that we'll be able to tell you the capacitance, the capacitive reactance at a particular frequency with a NanoVNA. What we wouldn't be able to do is tell you the picofarad value at, say, like a standard frequency that a multimeter would put out, which is typically a very, very low, somewhere in the hertz range. So the thing is that they're joking around about Sasquatch. What you typically do is you look at a capacitor, you get a picofarad rating on that, and then that varies as you vary your frequency through that because you have a reactive component.
And Rod's saying he measured it 22,330, which is about in range because you're never going to get a precise measurement on anything in these ranges. So when you measure a resistor, it's always got a tolerance. When you measure a capacitor, it's always got a tolerance on it. Things are never black and white like they are on your math test. The math gets you really close, and then you've got to dial it in based on the environment that you're in. And so the math is still correct, but
Right.
I don't have the measurement of where my ground is below the earth at my house and where the ground is below the earth at Ape's house. So I can get it measured and dialed in here with all the math that I have for all of the constants that I have in my area. And then I'd ship it to him and it would get bumped in shipping. And then he's got a different ground and he's got different measuring tools and that kind of thing. So,
Yeah, well, what's cool about that, or what's interesting, I should say, is that depending upon the multimeter that he used, like the length of the leads can add capacitance to that, right? Or if you're using alligator clips versus like the hook clips or whatever, it can mess with it. So he said about 30 to 320 is what he said. So that's about 300, which is what the marking is on the side. So that's totally believable to me.
I got to find out how to get down in there and
He said
connect that
20
one
to
lead.
330.
20 to 330. Yeah.
Yeah. So you actually have to solder that piece in there, don't you?
I do, but I'm going to do that after the stream is over, maybe tomorrow. So keep them busy while I get this thing connected.
So yeah, like I was mentioning, when you have these, the chassis is ground as well as your moving plates, and that rotor arm, we'll call it a shaft that goes through the center of that, is all your ground, and then your center conductor would be on the stationary plates, which are actually isolated from the chassis, and then you get capacitance as your plates pass each other, and then they create an electrical field between them. It's actually really cool. But what's crazy is that people don't really make these capacitors anymore. They're a relic from an older time where people needed big radios and shortwave was a thing in people's houses. And
Do a card trick.
Yeah, they're harder and harder. They're harder and harder to find or get on the market. So when what's up, MRD? When T.O. was telling me, hey, we're going to do this, I went out and I ordered a couple of variable caps, even though I've got zero plan to do anything with them. I figured I'd rather have them in the parts bucket than not have them in the parts bucket.
Okay, so I have the center post, which is connected to the fixed capacitor plugged in with one of my clip
It is
leads.
done. It is. It's based on the distance between the plates and the plate thickness, as I understand it.
Yeah, and then I have the other one connected to the outside rear pole of this device.
Sweet. So just real quick, just check and see if you've got continuity between those two leads. That if you do not, you're set. If you do, then we gotta take a look at the connections again.
So I put my meter into continuity mode, and you can always do a test. And
Chuck is saying that you need
there
a
it is.
vacuum capacitor. He needs a vacuum capacitor. Exactly.
So now I will connect that up like that. And these little rubber boots that they have on these leads move. So I do not have continuity between the left and right.
Nice. That's perfect. So, AG7 SMSA, once we got decent digital frequency synthesis, variable capacitor started to fade away. Yeah, that's kind of what I was getting at. Now it's nerds like us who want to add capacitance to antennas, so we can mess with their resonance. We're the type of people that need them.
And if you are a subscriber to Mike's channel, M0MSN, he actually built one of these devices by loading the plates up himself and 3D printing some parts and cutting some metal and some PVC and all kinds of stuff.
Yeah, you need to be a skilled craftsman to pull something like that. I'm not going to be able to do something like that.
He and Callum have been playing around with it. So we tested it. There is no continuity between the center, the fixed plates, and the variable plates.
Yeah, Don's saying he doesn't think that plate distance will handle 100 watts. I don't have the expertise to tell you that, but what I can tell you is I've seen some big ass variable caps like that are rated for like 50 watts. So it'll be interesting to see what we get out of it.
Mm-hmm.
So you're going to hook that what do they call the BNC banana jack up to your
binding post adapter is what I call it, or a banana plug adapter or whatever. And I happen to carry one of these with me everywhere I go, so I'm ready to roll on that. And then I have
just one.
Yeah, just one. I have all of these though. If that doesn't make up for it, I don't know what would. So I need to adapt this to the NanoVNA.
Yeah, the NanoVNA is going to have a SMA female on it.
Yep.
So you're going to need an SMA male in. The Chameleon F loop has a fairly big cap, and they don't want you to push more than 20 watts through it. My Palomar PT407 has capacitors about that size, and it's rated to 300 watts.
We've played with this thing up to 50 watts. But
yeah, I think that also the material that you use for the actual loop itself probably play into that equation a little bit.
Yeah. And so do we need to calibrate the NanoVNA or what? Because I wouldn't even know how you would calibrate it for something like this.
Well, you would calibrate it the same way you would for anything else. Our friend Canadian Joe was saying that we should take a look at it from 5 megahertz to 50 kilohertz to 5 megahertz, which would not get the 40 meter band, but we can do that. So what you want to do first is go into the set your start and stop frequencies.
So he said 50 kilohertz?
Stimulus. 50 kilohertz to 5 megahertz.
Okay. Stop is 50 kilohertz to 500, right?
50 kilohertz to 5 megahertz. So you just hit 5,
okay.
and then, yeah, there you go.
And then we'll do calibrate. And we'll do calibrate again. And then we need the open, which it's already open. Good. And then we need the short. I know if we don't do this on stream, everybody's going to ask us.
Well, we'll be criticized on QRZ. Don's saying keep increasing the voltage until it arcs. That's how I do
Exactly.
it.
Exactly.
Test
your plates aren't right. It have that little blue orange tint to it, kind of like muffler pipes. And then there's the load. And then we are done. And then let's just save that as save 0. You're all we're looking.
Yeah, they're saying that the deal with those loops are they create some pretty impressive voltages. Yeah, and I mean those things are no joke. You could get lit up on one of those things, and I don't want to get lit up.
Ape, have you ordered your SMA torque wrench yet?
I have not. I have a soft touch, so I can just like that. I can tell.
Okay, so we have it set up. And now we need to figure out what exactly is that we are going to measure. I've got channel 0 set for SWR and channel 1, which isn't even connected, set to Smith. So we need to change that.
I mean, you could do a logmatic, but that's just really going to give you your reflection coefficient. SWR is fine. So as you turn it, we should be able to see the dip move somewhere along those lines as you adjust the
So that's
knob
the
on
Smith
cap.
chart reading. Let me get this camera in closer for y'all. This is the Smith chart reading. And as I turn the dial, you can see the capacitance move. Sorry, the resistance move around.
Well, so would that should I can't see the grid real well, but that should be tracking right along the edge of your arc.
It is.
Yeah, yeah. And so when you take a look at it,
Capacitance is down and inductance is up.
It is, yeah. So I was going to say capacitance is at the bottom of that, and so what you're saying is that infinity, I believe all the way to the right is infinity. I have to go back and take a quick look at that, but that's exactly what I would expect that to see, because you have no inductance in there, because you might have a little bit from the connectors and alligator clips, but that as you turn that should just travel along the bottom of that arc. Now what we could do is we could probably introduce some inductance.
Yeah, and so you can see that it gets all the way down, and that right there is fully meshed, and we've got the entire arc on the outer ring.
Mm-hmm.
And then if you keep on turning, you start to unmesh, and it starts to unwind itself back up, and it'll eventually go to 0.
Well, let's do this. Let's get
unmeshed.
Let's get the fully unmeshed and the fully meshed values. It should be on the top of the NanoVNA in the blue for your Smith chart readings. And
Okay.
it's going to be some goofy number with some letters in there.
You ready to take some notes?
Well, I want Canada Joe to take some notes, and then we're going to let him do some ciphering, and he can tell us what do you got?
Well, it's hard to see. I guess I could look at the reading. Okay, so we're at the 0 reading on the dial, and it is 12.5 ohms, 38.2 picofarads.
38.2 PF. All right, let's go all the way the other way. Canada Joe, I don't see you in the chat. He was talking tough earlier, and now he's not around.
Now we got some numbers on the table. Math boy's gone.
Hey, break out your abacus now, son. Talking all that mess.
Oh, he's got a slide rule for this. So we're going fully meshed now, and fully meshed is easier to see. So we're at fully meshed, and we're at 6.62 ohms of resistance and 482 picofarads of capacitance.
And that's 482, no decimals or anything like that.
Correct.
So yeah, I don't know what that equation is, but we'll have to get him to do his math.
Yeah, and as I move around and touch the wires, the capacitance changes a little bit, as you would expect it to. They're asking about an online calculator, and there is an online calculator. So if you could pull that up, because I don't have a keyboard anymore.
Yeah, let me let's talk for a second before I do that. I don't know where I'll be able to find that, but if anybody's got a link to the online calculator, we would think that you're extra special, and you would get internet points for that.
So as the president of this ham club, I nominate Liberty Cave to go look for that link and bring it back to us.
Yeah, so I was just thinking we could add some inductance to this. If you do you have another set of those alligator clips?
I do.
So what we could do is we could take the inside of a clicky pen. You're right, MRD. It equals about 6 gold medals. We could take a coil from the inside of a clicky pen and then wire that thing up in series with one of those, and that would add some inductance. I don't know how much we're going to get, but that would probably adjust that blue line a little bit.
Okay, so we only need one of these alligator leads. We'll take the blue one, and then let's unscrew this pen. And you're talking about this spring right here.
Yep.
And that's going to act as an inductor.
It should.
And
If this works, I'm going to be like, damn.
This. And then I'm going to take the red one, because why not?
Sure. That should add some inductance in there somewhere.
And we're now at 790 picofarads, where we were at 480 before.
I didn't know it was going to make that big of a difference.
And this is now a bigger arc down here.
Yeah. So what is the start? Is the start still the same, or is that difference?
The start of what?
The arc, the start of the arc. I'm pointing on my
Well, the
screen,
start
you
is
can
at
see
0, and then it moved.
Gotcha.
It moved up. So the outer ring. I haven't read a Smith chart in a long time, but I think that it's 150 25, or is it 150 75 50 25?
Well, the thing is that because it's pulled off of because it was traveling along the outside of the outer circle, the fact that it pulled off means it's moving it north, which moves it towards your inductive region.
Yeah, so this is without it.
Right, and then it started to ramp up.
And then
I'm starting to think what else has got a big old spring in it around the house. You don't have a toroid that's got some wires wrapped around it already, do you?
actually I do. I have no idea what that toroid is, but it exists. So let's try that.
Yeah, replace that spring with that, because that probably has more induction. Somebody's actually, let's get a slinky.
We could get a slinky. All right, so I've got that. And I've got... that just took it right out. 33 picofarads. We went from 480 to 33.
And where are you on the dial on the thing? Can you move it at all? Or I mean, on the dial of the can. That.
Oh yeah, I can move that. We're at 100% meshed. And moving it isn't doing anything.
So does that give you an ohms resistance? I would imagine it's somewhere around close to 50.
So it's given me, the NanoVNA is telling me 20.
Mm-hmm.
And yeah, somewhere between 17 and 20.
So it's probably just below that line. So that's what you do when you, folks, when you build your antennas. This is very rudimentary, but you can use a Smith chart like this. Like, so if you have a transformer box, like a lot of times people will build an antenna and it's either super inductive or super capacitive. And then what you want to do is you want to add capacitance or inductance to get you on that, the center line that runs like an equator on that Smith chart should be around close to 50 ohms all the way across. You want to be in the center where you're gonna be as close as you can get, but well, we got something else going on there. But that's how you tune them in.
I told you I didn't know what that capacitor was. Now look at this thing move.
That's awesome. But see how the SWR dropped all the way to the bottom? See if you can get that SWR all the way back down to the bottom. Now you should be close to 50 ohms on the yellow measurement at the top of the NanoVNA. Should be close to 50.
No,
I'm sorry,
the yellow measurement is SWR. The blue, I'm getting 295 ohms, 11.9 microhenries, because now you can see we're above the center line.
Right, so you're more inductive
the center line
now.
is there. The current source, thank you very much. $9.99 super chat. I really appreciate that.
I'm sorry. I was chewing on a Hallsman elliptus. I got a little bit of a cough going on. I think I caught it this weekend from Ham Radio Dude.
That slink tenna, Don, that looks like something that would be very interesting. And so we've got, let's get fully unmeshed. And so what this toroid is wound as, this came, I'm pointing at it, it's not even on screen. This came from a silent Kia state with a bunch of QRP kits, and I have no idea what it is. It is 2 pieces of magnet wire that is run around, get my pointer out here, and my pointer's nice and metal, so I'm going to add a whole bunch of stuff to it. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 turns. It's 2 wires that are run around 11 turns, and
it's probably a 1-to-1.
These 2 here are gold colored, and these two here are red color. And what I had gold and red connected, and obviously that's not going to do anything. And so now I've got red and red connected, and we saw some magic happening.
Hey,
And now
Todd,
I've got
thanks.
these two
Same to you.
touching.
Now, Canada Joe, he better be sharpening his pencil up the way he disappeared like that after talking to me. Oh, there he is. He had to step away for a bit. Did you calibrate it with the alligator clips? We did. And so what I need you to do is
We calibrated it
your
before
pencil.
the alligator clips.
Yeah, so I hope you got your pencil out because I'm only going to say this once. We had 12.5 ohms at the low end with 38.2 picofarads. On the high end, we had 6.62 ohms with 482 picofarads. But then we started messing around. And we started messing around adding toroids and pen springs to it. And Shoot already saying, chewing the cough drop and washing it down with a Miller Lite.
Oh, hey, look at that.
You damn right, son.
I have way too much light on the subject.
No, but it looks good. You can actually see the Smith chart now a little bit better.
And now I've dialed out all of the SWR. And
so your SWR was probably at infinity at that point, right?
Yeah, and I don't think SWR is a fair measurement in this example, is it?
Well, what SWR shows you is that you have a matched circuit, whether that circuit is an antenna or this ammo can. It doesn't tell you that you have a resonant circuit. So that is a mistake that hams make all the time. You always see folks saying, well, I got my antennas resonant. No, it's not. It's matched. That means that you have effective power transfer. It doesn't mean that you have oscillation on a given frequency. Well, you would on a given frequency, maybe not the frequency you expect.
You know what we should have done with this? We'll have to do this on the NFED half-wave we're working on and show the difference. So the reason why the NFED half-wave works the way that it does is because at certain signals, you're taking the shortest path from one side to the other side, and you're going through the capacitor. And at certain other signals, you're taking the shortest path, which is through the big inductor that you wound 49-to-1 setup. So we would be able to display where that happens in the circuit by using the Smith chart.
When you were saying what we should have done, I thought you were going to say we should have wrapped it in a flour tortilla, deep fried it, and covered it in guacamole and salsa.
I like what you're thinking.
Yeah. Nico's saying, will it antenna variable cap edition? He's the 61 guy, right? He's one of the shenanigan guys in the 61.
Oh yeah, he's been a big help. I don't recognize him with the Nico in front of his name though.
Yeah, I did at first. I was like, who the heck is that? But then I saw the second line. Well, what else we got that we can plug in line with this thing? Because I'm kind of like what we're doing here.
Well, you throw out some suggestions, and I'll tell you if I've got it or not. I've got antennas laying around. That was the toroid that I had. I got smaller springs, but I'll probably lose the spring in the middle of the. We'll put it in with some beer.
Well, we could probably add. How many alligator clips you got in that bag?
I got a ton of them. How many do you need?
Well, let's get the spring and the toroid in there and see what happens.
Oh, jeez. Okay, now where's the spring? I lost the spring. There it is. I got no lights on over here. I can't see anything anymore. All right, so we got the spring in there, and then I'm going to disconnect. There it goes. I've got to keep these two apart because they're close enough together that when they touch, they obviously short circuit.
Right. Cancel it out.
So we'll plug that in like that.
There we go.
And then we'll plug this in like this. And then we'll spread these two apart. And now we're at 13.6 microhenries. Did you write down where we were last time?
I did not, but we're still waiting on. We just want to get the original measurements. And I've got just so everybody's playing along. It's the Cherry Hall's Relief, so it's like a Cherry Miller Lite, kind of like a Cherry Dr Pepper, but just a Cherry Miller Lite.
So when you start putting toroids, inductors, spread out springs, inductors into play with a Smith chart, this Smith chart takes on a whole new understanding, whole new level of understanding. Because if you study for your amateur extra test, you're going to run into Smith chart questions, and inductance is on the top and capacitance is on the bottom, and this ring means that and that ring means the other thing, and this is what you're looking for. But until you actually get this stuff out and do this, and what I've got right here is a $50 NanoVNA. I've got hand-me-down clip leads from my father, who got them from his aunt's husband before he died, and a banana plug binding post adapter, and this toroid and this magnet wire is probably another $8. So
Yeah,
we're
like
in
that.
this for 60-70 bucks, and ready to roll with like what this actually does from a practical standpoint.
And can't you see how much fun we're having? We're overjoyed over here.
Oh, this is exciting stuff. I never thought it would light up like this. I don't think that yellow SWR trace is useful though. There's a couple of different measurements on this device, and I don't know what really the rest of them are. So let's go into.
Well, while you're doing that, Tio, let's talk a little bit about that SWR trace.
Okay.
You folks see how sharp that V is, right? Compared to, like, if you hook that up to your DX Commander, you would have a very wide U in there, right? Not that V, and that is because when you make a circuit like this with inductance and capacitance and not using a resonant antenna, you start to get more high Q readings, and that is a sign of high Q, is how tight your usable bandwidth is over a set of frequencies. So that's why that V is so sharp like that, and that's why, like, when you make serious compromise antennas like a Wolf River coil, and everybody's gonna be like, "Don't say nothing bad about a Wolf River coil," but a Wolf River coil uses that big old inductance coil to make that antenna look longer than it really is, and that tightens your SWR dip into more of a V. Not as much of a V as a magloop, because magloop's even smaller, and then you're using capacitance there. But when you start to play trickery with your antenna by introducing artificial, and people are like, it's not artificial reactance, you start to tighten that V up. There we go. We got Bobby Ferguson, and I don't know if that's math or spelling, but he's saying frequency is 1 divided by 2 pi r times r times c.
And this is actually Chief's antenna that we're playing with right now, and he's like, "Oh, sure, yep." So we did a show on manual tuners before, and this is exactly what you do inside of a manual tuner: is you vary the capacitance and the inductance in order to find the resonance of your circuit and get your antenna happy. And you're basically trying to find that 50 ohm match for your radio, at which point your radio is like, oh, this sounds great. And your ears hear it too. If you've got a tuned antenna versus an out of tune antenna, it definitely sounds better.
Yeah, and like I was saying, people will probably get bent out of shape, but with ham radio, we go for a matched antenna more than we go for a resonant antenna, because we're always looking, and that's why we measure SWR as opposed to inductance, right? Or not impedance, imaginary impedance based off of frequency, because we're concerned about the most efficient power transfer from our radio to our load, the load being the antenna. So when you have a match, a 1-to-1 match, you're getting all the watts out into your antenna to either be absorbed and dissipated via heat or broadcast as a signal into the air. Hopefully the most of it goes into a signal in the air. And that's what hams are really, really working towards.
Yeah. So let me get my pointer out here. And I believe this mark right here on your Smith chart is 50 ohms.
It is.
And so what you're doing so I've got an inductor here, and if you look inside of a manual tuner, you're going to see a pi network or an L network, and that's just a fancy way of saying what the shape of everything is. In a pi network, it's going to be a capacitor, and I can't even display it. It's going to be a capacitor, an inductor between them, and then another capacitor on the far side. And so you want to get that inductor dialed in real close to where you hear the most amount of noise, and then you want to move the capacitors around until you get that 50 ohm mark lit up. And that 50 ohm mark, again, is going to be right there. And you can see this, and I hit the screen. You can see this moving around, and this is not.
Oh, so you're see if you can get that blue line across that center, right in the center. You're close. Now, if you move your marker, so you see your marker is that little chevron along the blue circle.
Yep.
you should be able to move that to the center of your Smith chart. And that would tell you your closest
Right
to
there.
resonant yeah. So what frequency is that?
So this is 50 ohms on the blue and 1.8 on the yellow. 250 m 1/1.8. I don't know what those measurements are. 250
So
m
that would be your
meters.
yes, that would be 1.8 megahertz. So it's like a what was that 160 band?
160 band. Yep.
So so this is really great, right? So when you take a look at that, like your SWR looks perfect, and you're saying that, hey, you know, we got a 1-to-1 match on 1.8 megahertz, and so that's where my antenna is resonant. This is just a matched network. It is not. It is not an antenna. When you hook your radio up to this, you ain't getting nothing, except for some static. But no, that I didn't expect us to be able to get it to land right there. So that's pretty cool. I'm actually things that get a nerd excited like that. That is awesome.
And so where we have this antenna set up is inside of a building that's covered in stucco. And so we believe that there's some wire mesh.
Nice.
And it's in the middle of downtown where I live, you know, the population under 1,000 downtown. So what is that, about 600 of them live there?
So you have tell us a little bit. You were using hardline as the outer loop of your mag loop, right?
Yeah. So we've got I'm not sure if it's LMR 400 hardline or if it's Heliax hardline. Let me see. Oh, I don't know. Do I even have it? I might even have it on the machine. Oh, we're going to get a practical demonstration here.
Oh, something happened.
Something happened. What?
With the Smith chart.
Oh, the connectors are touching.
I got you.
So it's a short.
All right. Well, you're looking that up. I'm taking. We got 50 people watching right now. So I'm going to ask everybody, go on and do me a favor and click that thumbs up button for TO if you don't mind.
All right. So this is a piece of. Let's see how this works.
I'm down at the club.
Somebody's at the club shack.
Neat. This is a magloop antenna that we've been working on.
This is what this thing looks like, fully
found
assembled.
This old variable capacitor.
Nice.
And we think it's out of an old Yaesu rig somewhere, but this thing is smooth. It's gear
Velvet.
reduction. So when you turn this,
Velvety
let's take a look
smooth.
inside. When you turn the knob on the variable capacitor, the capacitor itself moves very slowly.
This is all sunlight right
compared to
here.
how much you turn. So it's got a little bit of a gear reduction on there. And then this is an
Don,
old
you can hit the button as many times as you want, as long as they're all odd.
$7 ammo box that I got at a local gun show. And if you know
Hawaiian
loop
Tide.
antennas, then you know that these things are extremely sensitive. So what I'm going to do is I'm going to plug in the 705 and show you the SWR plot on this
Let's
thing.
pause this thing. Let me see if I can rewind it a bit to some useful spot. Nope.
$7 for that can.
I know, $7.
What did you get that at Menards?
No, I was at a gun show.
Nice.
I'm trying to
We
find
looks
a
like we got
picture
ourselves
of
a
the whole
Kenwood.
thing.
We got ourselves a Kenwood in the background over there.
Oh, Ape, I am disappointed. That is not a Kenwood. That is a Yaesu FT450D.
All right, well, cut a corner off my card. I was looking at that knob, and it looked like maybe it's the Miller Lite talking, but it looked like it was in the center of that radio.
You got no corners left on there, my friend.
It's been around for a while.
This loop that we've got going around the outside, and I published this video, and I knew we weren't done with the antenna, and we're still perfecting the state of the art here. You can see that the capacitor dial is up on top. What we really need to do is turn that down on the bottom, because when you reach inside of that loop to make that turn, you're adding capacitance yourself. And so we're going to turn that thing upside down so you can reach underneath and tickle it from the underside. And then you're not as much of the circuit. And this is that hard line. And all we're using this could just be coat hanger wire. This could be old speaker wire. This could be whatever. But this hard line keeps its own shape, so I don't need to worry about it too much.
What about making that dial face forward, though? You just probably can't do that based off that stand.
there's like human interface problems. And then this part here, this smaller loop, is where you can actually see the braid and the center conductor of the coax connected that goes off to the radio. So this is actually where your radio is connected. And then this here is a big inductor with a capacitor at the bottom of it, which is the thing that we've been playing with. And that's how you get the thing tuned in. And you really don't need to have a tuner with this. But this thing is so touchy that there's actually a little bit of a benefit of having an external tuner to dial it in just right when you pull yourself back out of the circuit.
So when you use that, you're saying it doesn't work well, though, right? But it might just
Well, it doesn't work well
because
because we got to get it outside. Yeah.
Gotcha. And how did you get the dimensions for the inner and outer loop?
I kind of sat there and answered some emails while the other guys in the club went crazy on measuring those dimensions. And I really think that it was just kind of like, let's just do it, as opposed to a whole lot of math. So I want to say that outer loop is probably 6 foot in circumference, maybe a little bit more. And then the inner loop looks like it's about 1.5 feet to 2 foot in circumference.
Yeah, I don't know if there needs to be a specific ratio or anything like that to the loops or not. But Chuck's asking if that's Heliax, and we are saying that we believe it is Heliax.
It's either Heliax or LMR 400. I'm not 100% sure. The guy that would know is not here, but Bill or Rod might know, and they've been watching. So yeah, this is just like every other loop antenna that's out there, and they are kind of finicky. But we always talk about this in ham radio. Every antenna is a compromise, and you have to figure out what that compromise is for you. That compromise could be I want ultra portability and lightweight, or that compromise could be I want, I've got all the land in the world and I want to spend, $10,000. This is not $10,000.
Don wants to know why a loop with an LNA instead of a cap at the bottom suddenly becomes wide-banded on receive. And that's a good damn question. I'm not smart enough to answer that one.
Yeah, me neither. That's why I brought Ape along, and if he can't answer it,
I think it has something to do with the inverted sinusoidal pulses that you get from the turbo encabulator, but I could be mistaken about that.
Inverse reluctance?
Yeah. The capacitive directance coefficient goes up.
Well, once you synchronize the cardinal gram meters, everything's fine from that point forward.
But that's the tricky part, right? And so that's
yeah.
That's where you need a good calibration. But it is a good question, Don. We'll have to see if we can figure that out. See, now I'm thinking we need to have a Coffee and Ham Radio's Magloop build edition.
I don't know if we find a way to finish it. There are a couple of automatic magloop tuners as well that can sense the SWR, and the Alex loop, I believe, is the one. He's got a little like clamp-on light that as you turn the dial, it'll just light up based on what frequency you're putting into it.
I'd go get it, but it would be a cluster. But I've got this box. Maybe I'll bring it in for one of the Saturday or Sunday shows from MFJ that has a capacitive and inductive knob on it. At least that's what I'm assuming. I haven't cracked it open yet. And then it's got a terminal for one side of a loop and a terminal for another side of the loop. So it is a loop antenna. It is not a mag loop. And for like 20 meters, I believe the loop is somewhere around like 17 feet long. I'd have to go back and look at the chart. But so you just put this big ass loop on there, and then but the wire is exposed right there where you're tuning it in. If you touch that, you're going to get zapped. You're going to get zapped good. So it's a loop. It's just not a mag loop. That might be fun to play around with. And I'm saying it's a capacitor and an inductor. It could be two capacitors. I don't know.
Could be.
That might be something to check out.
Let's switch back to the other view and see if there's any more questions that we can answer from all you fine folks at home, and maybe learn something together. I don't know.
No, but I'm interested to see how that loop evolves over time. Because I mean, what do you figure you have in parts in that loop total with the?
So a lot of this stuff is hand-me-down type stuff. Stuff that we've had for a while. We call it accumulation. Let me see.
And then this is an old
video backup. It's on a roof mount, TV antenna mount, and then we're using some PVC parts. So you can see the roof mount TV antenna tripod at the bottom here. And then we've got a piece of PVC that goes up, and that's basically just for framing. And then this
Right.
$7 ammo can has got some zip ties on the back, zip tying it to the loop. This T was here for another part of the project, and that didn't really pan out. So it's just kind of leftover type stuff. And then at the top, let's see if I can get to the top. Where's the top? I don't know if I have a top picture on here. All right, so there's not a top picture, but at the top is another T, and
Yeah, you had.
got
I saw it. I saw you have the cable just going right through the T.
yeah, and
You know,
that's
there's
just
a guy who
holds
built
up
one
there.
with a hula hoop. He took a hula hoop and he ran like cable like 8 times through it, like just regular wire. It's very good, Cameron. Thank you for asking. Loops are directional, so they would need to be rotated. That is correct, unless you pointed it towards Europe. DBD saying that hell, that knob's $30. Did you freeze up,
Yeah.
Tio? Or, oh no.
No, I was focused on something else.
But see, that's what's cool is that when you get the fellers together, you know what I mean. Everybody starts looking in their parts bucket. You know, you might have all the stuff to be able to build like a little loop antenna like that. You know, or any other antenna for that matter. So that's why I said earlier on when you started talking about these variable caps, I ordered a couple of them, like coming from like Thailand or something like that. But
Yeah,
it'll definitely be you know, good addition to the parts bucket, and then maybe we can do more exploratory work. What I actually like to do is build a tuner, but I would build a T tuner, which would have your capacitor, and then inductor in the middle, shaped like a T. I'd like to build one of those, but I'm not sure I know what I'm doing.
So Bill's asking me about the BTV. What do you want to know about it? I don't know if I could fit that on my workbench for the show.
What is he talking about?
And he's talking about the Hustler BTV. We've got one of those down at the Club Shack also, and it's a vertical antenna, and the BTV stands for band trapped vertical, I believe. Yeah. And we've got some ground radios on that, and it's an aluminum pole, and then each section has a trap on it. So think of like a linked dipole, only it's vertical. And that's a fantastic antenna, and you'll see those all over the place.
Yeah, Canadian Joe saying T-tuners are easy. He's building the eBay kit right now. Yeah, I've seen a couple of those T-network kits and thought about ordering them. I probably would just build one from scratch. It's not something that I think I would use. I would really just build it as more of, hey, I learned something today kind of thing. And then Liberty Cave is saying that the Palomar PT407 is a T-network type tuner.
So those MFJ Versa tuners that everybody has at least 3 of in their shack, those actually were kits. I didn't know this, but you can get it in a kit form.
Yeah, and it's like $12 cheaper than the built one.
Yeah.
You know, I'm all for getting the kit, building and learning, though. I think that is something. Now, Hackaday has an article on the spiral loop. I don't know what that is.
Yeah, and M0 MSN Mike is making a figure 8 loop, and that looks pretty interesting. So that's what he built that big capacitor for, and I believe the capacitor goes in the middle of the figure 8. So I don't know how much better that would be than a regular loop, or if it adds any more bandwidth to it, or what. But it's an interesting project.
Yeah, and then I think Don was saying, I could be wrong. Somebody was saying that that variable cap must have been expensive. But you see, the thing is, you can get stuff like that on deals at the Ham Fest, right? Like if you got a guy who's got a whole mess of them, he's just trying to dump them. You might be able to get them on a deal, but then if you get somebody on the eBay, they might want to charge you an arm and a leg for that. Like that.
Right.
That's one of the things. Caps. I was looking at the shipping cost more than the damn cap.
Yeah, that's how it is with those parts I'm looking at for the amplifier that I got to repair now. First, finding the parts is interesting because they're either out of stock and won't be in for 48 to 52 weeks. Well, I ain't got that kind of time to wait. Or
Well, you need a
we're not
transistor,
100%
right?
Sure. I need a transistor and I need a diode, and they're surface mount parts. Let me see if I can grab a
surface mount.
picture.
I was gonna say, if they're through hole, I would be calling Thump up because that guy's got parts He got a lot of parts.
So let me pull this picture up, and we'll have a video out on this once I get it figured out.
Don, I've seen people selling variable caps at FanFest, and I just didn't buy them, which was just, I won't make that mistake again.
So this is the inside of the Zygu XPA 125B amp, and inside this red circle over here, you can see this this transistor Q10 is a little worse for the wear, and then this diode D17 actually has a hole blown out of the center of it. So these are the parts that I'm looking to order right now, and I've got some parts names, and I've got some parts that might be compatible with those, but
I think I have a better
Not
picture
sure
of
yet.
that shows
I
in a
think you do.
little bit more detail there. So in the Toads Discord, some folks were saying that there wasn't enough press around Tio smoking the amp. So I put this together. I guess it was Saturday morning, something like that.
So
That is a
Alan's asking
bummer.
what happened. I'm not 100% sure, but I believe that in the cable that you make to connect the amplifier to the rig, there are a couple of wires that are labeled NC, which over on this side of the pond, that means they're not connected to anything. And I think maybe there might be a translation issue where over there, that means never connect these to anything. Like do not connect, as opposed to they're not connected. And I had the amp turned off. It was not plugged into the radio. And I think I shorted two of those wires together. And that's on me. I totally admit that I should have, taped those off and insulated them properly and all that kind of jazz.
You're
But,
saying while it was
the reason-
off, though, you shorted it, right?
Yeah. So I don't think that amp turns off all the way. Most modern electronics don't really turn off anymore. So there might have been something going on there. But so
You could have
here's
caps, though. You not variable caps, but you could have electrolytic capacitors, right? Or
Yep.
in there filled up with juice that just were itching to
they haven't discharged yet, and there'd be enough voltage
right.
in there going the wrong way. So yeah, so Ron's right there. He says he thinks it means do not connect to anything, not that there's no connection internal. And another one of the members of the Toads Discord, when you are wiring up, it's on the back of the amp, they're using a PS2 mouse connector, a 6-pin mini DIN connector. And so on the chassis side, it's pin 6 and pin 5. And on the connector side, it's pin 5 and pin 6. And he wired them backwards and connected them up, and he blew the same two parts. So
Yeah, I think the
it's
NC stands
possible that's the
for
answer.
no connect.
Right.
But yeah, that seems like that's a pretty easy mistake to get. And you Googled it, right? There was a couple other fellers out there that did the exact same thing, right?
Yeah. And then these parts are unobtainium right now. So when they come in, I'll get out the. I've got a cheap hot air station. I'll try and see if I can desolder those with the hot air station, and I can't make it any worse than it already is. So that's
Well,
my view on life.
Josh from Ham Radio Crash Course, he left his rig expert plugged in overnight to his antenna. Cool. And yeah, and I think what he was saying is the static buildup on the antenna. It might have even been more than overnight. The static buildup on his antenna kept pushing juice down into the rig expert, and he smoked 2 surface mount devices like that as well. Mm-hmm. He was successfully able to repair it, but that was before the chip shortage.
Yeah. And right now, I just can't get the parts in hand. So if I get the parts in hand and they go back together easily enough, then I will rewire the exercise and see if we can get them to blow again. And if they're a humongous pain in the butt, then the video will be, look at that, folks, it works. See you later.
Yeah, or I guess worst case scenario is you call your friends over at Zygu and ask them if, hey, can I get this repaired or something like that.
Right.
Like you would think that in order to repair it, you could just pull the board and send them the board. You wouldn't have to send the whole damn amp.
Well, they probably don't know 100% what's wrong with it, and I don't know 100% what's wrong. Those two things are obviously burnt out, and it was pure accident that I found them. I mean, when it's a very distinct smell when that happens, and so then you just open it up.
It's a smelly smell, right? It smells smelly.
Yeah, exactly. And so what happened was I set it on the workbench, opened up, and then I reached over for my magnifying loop, my jeweler's loop, and as I opened up the jeweler's loop and put it on top of the amp to start looking, the parts were already underneath of it. So it's my magic jeweler's loop.
Don says he lost his AA600 to static buildup. Damn, that's an expensive one. So one tip I always give people is when you're going to hook up any kind of coax to any kind of test gear or test equipment, take something metal. Yep, take something metal and short it out before you do, just to make sure that you discharge any static buildup that's in there.
Yeah. I think this hour went by faster than most, so it got to be real exciting there. And
I didn't even realize it was
tune
that
in
late.
next week because John Amateur Radio on the Air is on, and I'm going to hit the goodbye button. Thank you all for being awesome. Thanks, Abe, for being here.